Next bullet point asks you to evaluate tangent of x minus 270. You think, okay, well, I'm not going to distribute. I'm not falling for that old trick. I have to use the tangent difference formula. Makes sense. I would think so. So we're going tangent of x minus tangent of 270 divided by 1 opposite plus tan of x, tan of 270. You're like, how is this in things to think about? We know how to do tangent difference, but wait. Remember what I said about constants. Let's figure those out. Now, I think the easiest way for tangent is probably just to go with the sine over the cosine. So if you could tell me what sine of 270 is, and we'll divide by the cosine of 270, we should be in business. The sine of 270, if you do a picture real quickly here, 1, 2, 3, 4, there's 2 pi, there's 3 pi halves. That's your 270 marker. So what is sine? Well, sine does this, and where are you at? Where'd you go? Down here, up here. Here's sine. What's the sine of 270 or the sine of 3 pi halves? Easy. It's -1. We can clearly see that. What about the cosine? Well, I know cosine starts up here, drops to the minimum, comes back up here, and then to the maximum. So cosine. What's the cosine of 270? Oh, it's easy. Cosine of 270 is 0. What's -1 divided by 0? Well, that would be the University of North Dakota. Undefined. You cannot take -1 divided by 0. The tangent of 270 is undefined. You have issues here. You have issues at 270. We cannot say this is tangent of x minus undefined over 1 plus tangent of x times undefined. Undefined is kind of like infinity or negative infinity, but we can't actually replace those. And it's highly illegal. Bad math. So, what do I do with this? The answer is you don't go this route. You're going to have to go a different route. And the hint was when we evaluated this tangent of 270, we said it's the sine of 270 over the cosine of 270. So you're going to have to say, well, I can't use the tangent difference angle. That would be the easiest way. It just doesn't work. I'm going to have to go with, well, I guess this is a sine of x minus 270 over the cosine of x minus 270, which it is. That will avoid the undefined issue. So now when we go through this, the sine difference formula would be sine of the first, cosine of the second. Same plus or minus, so minus cosine of the first, sine of the second. And this will be divided by the cosine difference formula. It goes cosine first, cosine second. Opposite of the plus or minus, so minus goes to plus, and then sine first, sine second. All right, you have some constants here, 4 of them to be exact. Just replace those with what they are, and we've already said what they were when we graphed the sine and cosine. At 3 pi halves, that's 270 degrees. We're going to say cosine of 270, what are you? Cosine of 270 is, nice round number, 0 minus cosine of x times the sine of 270. Careful, that's -1. And same thing for the denominator, that's cosine of x times 0, cosine of 270, plus sine of x times -1. All right, cleaning this up. Well, you're gone because you're times 0. You're gone because you're times 0. So what I get, a negative times a negative is positive. A positive times a negative is negative. So you got negative cosine of x over negative sine of x. That is not a very good job. Equals negative, you are cotangent of x. And that's how you would evaluate that. So sometimes you have to go in a roundabout kind of way because the direct identity doesn't work. Because identities are true for all values of the variable that are in the domain. 270 degrees is not in the domain of tangent. That's why we had an issue. That's why we kind of had to go around that issue. Because you can take the tangent graph and shift it to the right 270 degrees, or 3 pi halves, spaces, whatever that turns out to be on your graph. It's legal. It's a graph, and what it graphs is negative cotangent. You couldn't figure that out from this stuff. All right, final bullet points. We have what techniques are used to verify identities, and what techniques cannot be used to verify identities. So let's split this up. Can and cannot. All right, for the can, what can we use? Well, a lot of different things. When we verify identities, well, we can use other known identities. What do you mean? Like your reciprocal identities? Your Pythagorean identities, that's a big one. Should be saying IDs. We could go your quotient identities. Quotient identities, double half angle, double slash half angle. Identities, your sum difference identities. Sum difference identities. I mean, there's others, the cofunction identities, the even odd identities we talked about. They pop up rarely. Let me just put down even odd identities. That's just using other known identities. I mean, there's a lot of stuff there. Well, what else could you use? Well, you can get common denominators. For the purposes of adding two fractions together. Well, you can do the opposite of that. We call it the Hart method, but it's just the reverse of getting common denominators. You're splitting this up back into two separate fractions. So don't be quoting this to other teachers. It's a made-up term. Hart method is just an easy way to visually see this. You're just splitting one fraction up into 2 or 3 separate fractions. What else? Oh, I am out of room. Let's keep going with the can. Continue on. What else could we use? We could use factoring. Factoring's a big one. We could multiply by conjugates. Conjugates. Many techniques that we use. Factoring, multiplying by conjugates involves a lot of stuff there. So, those are the cans. Now, how about the cannots? I don't think I have room over here, so let me move it back over here. This is not a long list. I mean, obviously the things you cannot do is you can't erase part of the problem or erase squares so things work out better. What I'm talking about, what you cannot do. I really have just one thing. You don't ever do this. Never. Under any circumstance, for any reason, never treat the identity you're trying to prove as an equation. Never, ever do that. That means don't multiply both sides by something. Don't cross-multiply. Those are things that you do when you treat it like an equation. Adding, subtracting stuff to both sides. Don't ever do that. This is really the biggest no-no. So if I say, to verify this identity, first I added sign to both sides. You got a problem. There are not both sides. There is the left side, which is a simplifying problem. There's a right side, which is a simplifying problem. You need to simplify both sides to meet somewhere, right? Somewhere in the middle. You cannot start multiplying, cross-multiplying, anything like that you would do to both sides of an equation. Because once you say, oh, it's an equation, well, you've already said that it's true. And if it's already true, what's the point of proving it? Right? And there is no point once you assume it's true. So we can't just assume things that we're trying to prove to be true. Otherwise, there'd be no merit in that. All right, that is it. On our next video, for our lessons, I'm going to try to be more interactive with the camera here like I would at a normal classroom. Here I was just putting my head down trying to get through all of this because the one video I made, which took just as long as this, close to, about 3 hours, the sound didn't come out, and so that was a complete waste, so I had to come in here and do the whole thing again. But good thing I love mathematics and I love writing this stuff out. It was a lot of fun. I enjoyed this. But the next video, when we start teaching things, I'll be more interactive with the camera. Not that that matters. Not like I can say, are we good? Do we understand that? It's nobody in the audience. So just know the next videos, I'll try to be more eye contact sort of thing. Not that that really matters. Your job is to learn this. All right.